Look at this equation. D represents drug, R represents receptor. DR is binding receptor. Drug bind to the receptor could induce effect. This equation is reversible. E represents effect. E max represents maximal effect. RT represents total receptor. The ratio of E to E max equal to binding receptor to total receptor. From this equation, we could get two results. 1. When the drug concentration large enough, larger than Kd at all, Kd could be omitted. So, the ratio of E to E mass equals to D divided to D equal to 100%. It means when the drug concentration is large enough, all the receptor was occupied, they could produce maximal response. 2. When half amount of the receptor was occupied, or 50% of receptor was occupied, we could get the result D equals to Kd equals to Ec50. We have done Kd before. Kd is the concentration of drug that 50% of receptor was occupied. 50% of receptor was occupied, its concentration we call Kd. Here, we also could deduce from the equation. Kd, we call it equidifferent dissociation constant. It represents drug binding affinity. Kd is low, binding affinity is high, and vice versa. Reciprocal Kd, we call it affinity constant. We also call PD2 affinity constant. We order PD2 equal to log reciprocal Kd equal to minus log Kd equals log minus Ec50. PD2 represents drug binding affinity. PD2 is high, binding affinity is high. Multiple choice. 1. Which is the highest binding affinity? A. Kd2 equals to 10 power minus 1 mole, minus 2, minus 3, minus 4, minus 5. The answer is E. Because Kd2 is low, the binding affinity is high. 2. Which is the highest binding affinity? PD2 equals to 6, 2, 3, 4, 5. The answer is A. Because PD2 is high, the binding affinity is high. 3. When Kd equals to 10 power minus 2 mole, what the PD2 equals to? A. PD2 equals to 1, 2, 3, 4, 5. The answer is B. Because PD2 equals to minus log Kd. Key point: pharmacology, pharmacodynamic, pharmacokinetic, drugs, receptor, concentration effect curve, graded dose response curve, hyperbolic curve, symmetric curve, Kd, Ec50, PD2.